All right, welcome to the state exam review series. We're going to do some seventh grade past New York State test exam problems. Going to kind of stick to the theme of proportional relationships for today. All right, so let's get into it. If you're not watching this on the live stream and you're watching a replay, I would suggest pausing the video and trying to solve these questions first before I go over them. That way you see whether or not you have gotten them correct. All right. So Megan reads the same number of pages in a book each day. So they're already telling us that it's going to be a constant rate that she is reading at. The table below represents the total number of pages she read at the end of a given number of days. Okay, first thing I like to do is label that this is my X and this is my Y, my independent variable being the days, right? They don't depend on anything. She can choose how many days she wants to read. And the total number of pages is my Y. It's dependent on how many days she read. So the number of pages she reads depends on how many days she was actually reading. It'll change with the amount of days. And my question is, how many pages does Megan read in one day? So whenever we get something that's asking us about a rate per one, we're looking for the unit rate, right? We're looking for what in seventh grade we start to call the constant of proportionality. So hopefully this formula, I'm writing it wrong. Hopefully this formula is secondhand to you at this point if you're a seventh grader. K, which is the variable that we use to represent constant of proportionality, is equal to Y over X. So it is as simple as taking any Y value from your table or your set and dividing it by its corresponding X value. So not just any X value from the table, but the X value that corresponds to it, that's paired up with it. So I'm going to go ahead and pick this first ordered pair, 2 comma 32. I'm going to write that as an ordered pair. That's 232. And I'm going to plug it into my formula. So K is equal to Y, which is 32, divided by 2. So K is equal to 16. So she reads 16 pages per day, and here is choice A. You want to make sure your answer makes sense when it's a word problem. So even before I did this work, actually, I should have gone through the answer choices to see if I could eliminate anything. So if you're looking at the answer choices and you could figure it out before I say it, I would definitely have gotten rid of answer choice D. D doesn't make any sense because we're being asked how many pages Megan reads in one day. But in our table, it tells us that in 2 days, Megan reads 32 pages. So the amount of pages that she reads in 1 day and 2 days are not the same. So answer choice D would have been out from the beginning, okay? And then if you want to just do some checking once you think you have your answer, if she does indeed read 16 pages per day, then I should be able to take any other ordered pair from this table. So let's say I took 580. And if it's true that she reads 16 pages per day, then I should be able to multiply 5 times 16 to figure out how many pages does she read in 5 days, right? So if it's 16 pages in 1 day, then 16 times 2 tells me she reads 32 pages in 2 days. 16 times 3 will tell me how much she reads in 3 days. 16 times 4 in 4 days. So 580 tells me that in 5 days, she should be reading 80 pages. So 5 times 16 better be 80, and it is. So that's how I know that I'm correct about how many pages she reads per day. All right, moving on, but sticking to this theme of proportional relationships because it's a pretty big part of the state exam for 7th grade, at least in New York it is. Let's go over this one. The table below shows the amount of money in dollars that Kathy earns babysitting for a given number of hours worked. So again, that independent, even though they have it labeled as H, that's my X, right? On a graph, that would be my independent variable. And then the Y is what they have labeled as D, which is the earnings. So the earnings depend on how many hours she works. So the earnings are dependent, they're Y. Based on the table, which statement is true about the relationship between the number of hours H she works and the money D that she earns? So this is one of those problems where you really have to read the answer choices before you even know what type of math to do and what you should be looking for. So let's look at answer choice A. It is not proportional. So I'm going to stop right there and annotate the word proportional, right? What does proportional mean? So if I had a graph, proportional means that it's a line that goes through the y-axis. All right, so proportional has to be a straight line Oh, that is not good because it does not go right through. So this is an example of not being proportional. If it's proportional, it needs to go straight through that origin. Okay, so if I draw an X and Y axis, my line has to go straight through that origin point 0, 0. It doesn't matter which way the line is going or how steep the line is, it just needs to go through 0, 0. So that blue line is also a proportional relationship. That line is also a proportional relationship, or that ray, I should say. Okay, so that's on a graph. I don't have a graph in front of me right now, so that means I should know something else about a proportional relationship. And that's going to be the fact that it has a constant of proportionality, meaning that every time I try to find that k that we just talked about and do y over x, I would get the same value. So every ratio of y over x should be equal, no matter which xy pair I pick. I have to get the same number. It has to be constant, okay? So it is not proportional because when the value of h is 0, the value of d is 0. Remember that I said h in this case is the same thing as x, right? So they're saying when x is 0, then y is 0. That's the ordered pair 0, 0. And I just told you that a proportional relationship goes through 0, 0. That's one of the requirements. It also has to be a straight line. It can't be a curve that goes through 0, 0. So this is not a good reason for not being proportional. If anything, the fact that it goes through 0, 0 actually would make the case, would be part of the evidence for why something would be proportional, okay? So answer choice A is out because it's giving me an incorrect definition of what proportional even means. So if a relationship is shown to go through 0, 0 and it's linear, then that's proportional. But this answer choice, if you really, really carefully, is saying it's not proportional because it goes through 0, 0. That's backwards logic. So A is out. B, it is proportional because the ratios between the values of D, remember I said that's Y, and H, that's same as X, are the same for each pair. The ratios between D and H, they're saying are the same. No matter which ordered pair I pick, I'm always going to get the same value for D over H because D over H is the same thing as Y over X. And we said that Y over X is our formula for K for our constant of proportionality. This would be a good reason. So the reasoning in B is correct, but now I have to see if it's actually true, if the ratios are equal. So the reasoning in D is correct as far as the definition of being proportional. It's saying that all of my Y over X ratios are equal. If that's true for this table, then yes, it's proportional. So let's find out if it's actually true. So we're going to take any of the ordered pairs from this table and we're going to divide Y over X. So we can start with the first one. My Y is 50 and my X is 4. So if I go ahead and divide 50 by 4, then I'm going to get 12.5 as what looks like it would be the constant of proportionality, but I can't call it that unless it's actually constant throughout the rest of the table. So for 50 over 4, my first order pair right here, I got 12.5. Let's check the other order pairs and see if we get the same thing. So my next relation is 5 and 62.50. So again, it's Y over X, that order matters. 62.5 divided by 5. And if you guys divide that out, we're going to get 12.5. So far, we're on the right track. You don't want to stop there because you don't want them to get you with the last order pair. So as tempting as it is to just circle B and move on, double check, especially on a test that's untimed and you have the time to do this, double check. So keep going and we're going to do 75 divided by 6. You will get 12.5. And then you'll do 112 divided by 5. Sorry, 112.5 divided by 9. And you will also get 12.5. So 12.5 here is our constant of proportionality. It was the same value no matter which order pair I picked. So that tells me that yes, B is correct. This is a proportional relationship for that reason. Okay. And if you want to check again, just like we did with the reading table before, 12.5 being my constant of proportionality in this problem means that Kathy is earning $12.50 for each hour that she babysits. So if I just took any number of hours and I multiplied it by 12.5, $12.50, I should get her earnings that's in that Y column. Okay. Next one, again, sticking with that proportional relationships topic. Joseph has a part-time job. The graph below represents the amount Joseph earns in dollars for the number of hours he works. So the number of hours he works is my X, my independent variable, and the money he earns depends on how many hours he works. So that is my Y, my dependent variable. But you see that on the graph, they already have that labeled for you. The hours worked is on the X axis and the earnings he made are on the Y axis. Based on the graph, which equation can be used to determine the earnings in dollars for every hour he works? So I see that this graph is a proportional relationship because it checks off the two things we talked about before. One, it's a straight line. And number two, it goes through the origin. It goes through that point 0, 0. So because I know it's a proportional relationship, the format of the equation is going to be y equals kx. All right, that's going to be the format for the relationship for an equation if it's a proportional relationship. So y is equal to that constant of proportionality times x. All right, so all I need to do that means is find the constant of proportionality. So we talked about that formula before. K equals y over x is your formula. So in order to use it, I just need one x and one y, but they have to be from the same order pair. So we can choose any of the order pairs we want, but they have to be lattice points. You can't choose, for example, this red point that I'm pointing out right there. That's not a good one because it's not a lattice point. It's not on a corner. So we'd be estimating if we pick that point. So we don't want to do that. You want to pick something that's right on a corner. So the 2 points they have laid out for us are good. Is there any other one on here? No. So we're going to have to pick one of these. So I'm going to go with the lower one because the lower the point, the less you have to simplify the fraction. All right. So this point right here, let's make sure we can read it. Ordered pairs go x comma y. So my x, always look at your intervals. Do not assume that each box is 1 on a graph. That's not always the case, all right? In real life, it's almost never the case. So that dot requires me to go over 2 on the x-axis. So the x coordinate is 2. And then it requires me to go up. This is not 1 that I'm going up. This is 10, right? Because if I look on the side, 2 boxes gets me to 20. So that means 1 box gets me to 10. So this is 10, 20, 30 that I'm rising, that I'm going up. So it's 2 comma 30 is that point. So if I use that formula that we wrote out, k equals y over x, I'm substituting in my y was 30, my x was 2, and if I divide that correctly, I'm going to get 15 for my constant of proportionality. And again, the format of the equation for a proportional relationship is circled in green here. Y equals kx. Once you find k, just substitute it and you're done. B shows us that equation, right? We found K, it was 15, Y equals 15X. You want to double check it? Easy. Pick another point from this graph. Let's take this one. That's going to be at 6, right? Because I went over 6 and then I went up to 90. So that's 6 comma 90. 690 is a point on this line. So it needs to work in this equation B. It needs to make that equation true. So if I substitute into this equation 90 for x, that 15 stays, it's my constant of proportionality, and 6 for y, it needs to make this equation true. 90 equals 15 times 6 is 90, so it does work. All right, that helps me gain some confidence that B really is my answer. All right, one last 7th grade question. A bicyclist travels 6.5 miles in 2/3 of an hour. What is the average speed in miles per hour of the bicyclist? So you're trying to figure out, again, that unit rate. So all we're going to do is divide. If we want miles per hour, you're looking to get it per 1. So we're going to have to divide that 6.5 by 2/3 to find out how far he would go in 1 hour. Okay, so let's make this mixed number that we have into an improper fraction. 6 times 2 is 12. 12 plus 1 is 13. That means that's the same thing as 13 over 2 as an improper fraction. Divided by 2/3. Now in 7th grade, you guys do have a calculator on your state exam, so you could just throw this in the calculator. But since I don't have one in front of me, I'll show you how to do it by hand. So 13 over 2 times 3 over 2, right? So if you remember from 6th grade or 5th grade to divide fractions, you keep the first fraction and you multiply by its reciprocal, by its flip, all right? So then that's going to give me 39 over 4. And of course, if I look over at my answer choices, I don't have 39 over 4. You have to know how to write things in multiple ways. So they could have given me decimals. Here they gave me mixed numbers. So I need to know how to change this back into a mixed number. 4 goes into 39 9 times with 3 left over. So it's 3 over 4. And my answer is D. But again, you guys could have just put that into your calculator since you're in 7th grade. All right, that concludes our 7th grade state exam review for today. We'll do a different topic next week.